Dr. Owl, Emma, I lost my favorite wrench. I am scanning the perimeter, but I can't see it at all. Oh wait, I just tripped over the mailbag. It is overflowing. It has been getting fuller every single day since you built me last year, Dr. Owl.
Ziggy, you are always losing things. But look at all those letters from our listeners.
That is wonderful news. What kind of questions do we have today, Ziggy?
Let me check with my 2 digital eyes. It looks like everyone wants to know how things work. Like, how does a toaster know when the toast is scared and makes it pop up?
I don't think toast gets scared.
Indeed. It sounds like we have a fantastic theme for today's episode. Let's dive into Ziggy's mailbag and uncover the science behind everyday objects.
Booting system, curiosity, on, logic, on, chicken dance protocol, stuck on. Book, God!
Ziggy, wrong button. Stop the clucking.
Hoot hoot! I suppose we're doing science and dancing today. Welcome to STEM with Dr. Owl. Here we explore how the world works.
With curiosity.
Protocol 404. If this show is fun, tell a friend. If it's not, it must be a software bug. Literally, there is a ladybug on my enter key.
Welcome back, explorers. Ziggy, what is the first letter in your bag?
This one is from a 7-year-old explorer. They want to know, how do fans work? Do they have tiny wizards blowing air inside them?
No wizard, Ziggy. But I know they spin really fast.
You are on the right track, Emma. Before we answer, let's play a quick guessing game. What invisible stuff is all around us, right now?
Oh! Is it air?
Spot on. Air is everywhere. A fan works by taking that air and pushing it toward you. If you look closely at a fan when it is turned off, the blades are not perfectly flat. They are slightly tilted or slanted.
Why are they slanted?
Because when they spin, that slanted shape scoops up the air behind the fan and pushes it forward. It is like how a snow shovel scoops up snow, but with air.
Beep boop. Next question is from Ryan. He is 6 years old and lives in Melbourne, Australia.
Oh, I love Australia. It is the end of spring here in the US, so it must be fall for Ryan right now.
Ryan wants to know how parachutes work.
Parachutes look like giant floating jellyfish in the sky.
That is a beautiful analogy, Emma. Before we answer Ryan, let's play a quick game of true or false. True or false? The largest parachute ever used on Mars was as wide as an entire football field.
I think that is false? Nothing is that big.
You are absolutely right, Emma. It was not a football field. But here is a fun fact. The parachute NASA used to safely land a heavy robot rover on Mars was still huge, opening up as wide as a giant house.
Beep. A house-sized parachute on Mars? Science-tastic. But wait, how do they work here on Earth?
Parachutes rely on a special force called air resistance. When a skydiver jumps, gravity pulls them down. But when they open their parachute, that huge piece of fabric catches the air underneath it. It acts like a giant upside-down bowl trapping the air, which pushes up against the parachute and slows the person down so they land safely.
We can test this. Explorers at home, try dropping a flat piece of paper and then crumple another piece into a tight ball and drop it. The flat paper floats down slowly because it catches more air, just like a parachute.
Okay, next question. This one is from Anwin, who is 7. Anwin asks, why do squishables slowly bounce back to their original shape after being squeezed?
Oh, I have a giant squishy toy right here. Look, I am stretching it really hard with only one hand. When I let go, it slowly puffs right back up.
That is a fantastic observation. There are actually 2 main kinds of squishy toys. Some are made of memory foam, which is full of millions of tiny air bubbles like a sponge. Here is another fun fact. Memory foam was originally invented by scientists at NASA to keep astronauts safe and comfortable when launching into space.
Whoa! So when I squeeze foam, I am holding space science?
Yes! When you let go of the foam, air slowly rushes back into all those tiny bubbles, puffing the toy back out. But other squishies, especially the jelly-like ones you stretch, are made of something called a polymer.
Polymer? What is that?
Imagine a super long chain of paper clips holding hands. When you stretch the jelly toy, those paperclip chains stretch out, but they are elastic, which means they really want to snap back to their original snuggle.
Wait, memory foam and paperclip snuggles? Does that mean my squishy toy can remember my birthday?
No, Ziggy. It just remembers its own shape.
Mailbag alert. Here's the next letter, Dr. Owl. My scanners say it is a really heavy question.
Oh, thank you, Ziggy. This is from Santiago, who is 4 years old. Santiago is asking about one of my favorite machines. But before I tell you what it is, let's see if Emma and our explorers can solve a riddle. Ready? I have no legs, but I can carry your heavy luggage. I stay in one place, but my back is always moving. What am I?
No legs, but back is moving. Oh, is it a conveyor belt?
I know this one. It is a moving floor that eats your luggage at the airport.
They do not eat luggage, Ziggy. But spot on, Emma. Santiago wants to know exactly how those conveyor belts work. A conveyor belt is essentially a long, wide band of strong material wrapped around 2 or more spinning tubes, which we call rollers. A motor turns the rollers, and as they spin, they pull the tight belt along with them in a giant continuous loop.
Last question from the bag. Reeve, age 3 from Arizona, wants to know how the hoses on fire trucks work. Do they have giant elephants inside spraying water out of their trunks?
Ziggy, you are so silly today. But fire hoses do spray water really, really far. Farther than my garden hose at home.
That is because of a very important word: pressure. Fire trucks carry a lot of water, but they also have powerful pumps. Imagine taking a juice box and squeezing it really hard. The juice squirts out fast, right?
Yeah, it shoots right across the table if you are not careful.
Exactly! The pump on the fire truck squeezes the water, building up high pressure. When the firefighter opens the nozzle at the end of the hose, all that highly pressurized water is forced out through a very small hole. That makes it shoot out super fast and incredibly far, so they can reach tall buildings and keep us safe.
Wow, so it is like a super-powered juice box pump.
Well, I think that empties out Ziggy's mailbag for today. You all asked some truly wonderful questions.
Remember, explorers, keep wondering, keep asking questions, and keep exploring.
And keep eating toast. Wait, I am going to build a new invention. I am putting a jelly squishy toy on a conveyor belt, pointing a fan at it, and... Uh-oh, My 2 digital eyes are covered in sticky jelly. And since I do not have ears, I cannot even wear safety glasses to protect them. I think I invented a mess.
Oh, Ziggy.
Until next time, everyone.
Hello? Is the microphone still on? I am currently stuck on my own conveyor belt, and the fan is blowing me toward the giant pile of mail. If anyone finds a jelly-covered robot, please send help.
Hang on, Ziggy. I am bringing a towel.
And that brings today's STEM adventure to a close. Remember, the world is full of wonders if you just know where to look.
Thanks for exploring with us. Don't forget to keep asking why.
Preparing shutdown sequence. Deleting. Browsing history. Deleting. Emma's math homework.
Ziggy, no! Don't delete that!
Just kidding. Robot humor. Curiosity stays on battery level 1%. Oh, almost forgot. If you have a question, leave it in the comments. My inbox is lonelier than a robot in a rainstorm.